On the shark bite, which numbers do we want to see, go over, have questions about? Want to just double check? I see a lot of ones, a lot of twos. Some of these can be done on desmos, so whichever ones those are, we're going to do this anyway. So for sure, 2, 1 and 2, and then the ones we can do on desmos. Right? 1 and 2 you can't do on desmos. These are things you have to know. So 5 times the difference, so we need parentheses because we're multiplying to something that already has an operation. The difference of a number, pick whatever variable you want, and 3 is equals 7. Bless you. Questions on that one? 2, we're looking for the range. Is that X or is that Y? Y. So we're looking lowest to highest. What would that be? We're looking lowest to highest. Because this is going to keep going down like that, and it's going to keep going up like that. So all real numbers should have been your range. You can use desmos for 3. So I'll show you the work and then I'll show you desmos. So the work would be finding the slope between those 2 points. So 0 minus 0 over -7 minus 5, which would give us 0 over -12, which is just 0. What type of line has a 0 slope? This is pretty much in my way. Say that one more time. Only showing y values. So it would be y equals the 0 45. It would be a horizontal line. Now you could do the point slope, put in a point, put in your slope, and go forward with that. So I'll show you that, but I'll also show you how you can avoid that. So if I did, let's say I chose this one, y minus 0 equals 0 times x minus 5. This is just going to become y. What's 0 times anything? You could have also looked at your ordered pairs and said your y value is 0. On desmos, if you wanted to figure this out, you would start off by plotting those points. You would notice that they fall on the same line, a horizontal line. So you would have to remember that that would be a y equals. And then you could either start to put in numbers you have. So we know x is 5 for one of them, x is -7 for one of them, and then y is 0 for both. That black is kind of hard to see. So then of the 3, three that go through both, the orange is the only one that does that. So that would be your equation. Now, again, with desmos, you have to know some of that stuff. It's not just given to you. Both of these can be solved using desmos. Someone read off what number 4 was.
Number 4 is negative 5x. Minus y.
Yeah. Okay, minus y equals. Okay, so if I have this drawn, I can solve for y without really doing the work for it if I know what my y-intercept is and I know how to find my slope. So I see another point here at negative 1, 4. I'm going to plot that point just so I can see it clearly. I can count my slope between these points. So that would be up 1, 2, 3, 4, 5, to the left 1. So my slope is negative 5. My y-intercept is at negative 1. They overlap. So I know that would be my new equation. So if you graph it and you know what you're looking for, you could find that without solving it, but you could also just solve it, either or. Questions on that one? So that was your answer for 4. So y equals negative 5x minus 1. And then I'm going to type this over here. I actually have it. I was going to say read off that one, but negative 5, let's do this also. X minus 3 minus 2x equals 46 minus 4x plus 1. Remember that if you have equations, those are things when you get to the SOL that you don't have to solve. Put it in, see where it equals. X equals negative 9 should be your answer. Now for tests and stuff like that, yes, you would need to know how to solve, but for SOL, you need to know how to put it in. Okay. Questions on that one? Right, take out your notes from last class, the parallel perpendicular lines. We're going to continue that today. Does anyone need another one of those? So I know we did example 1 last class. We're going to do a few more examples today. Let's do 2 and 3, and then I'll let you try a couple last class, we need to find the slopes of these points. So for AB, that would be 4 minus 2 over 5 minus 0. What would that slope be? Otis, 2 over 5. And then do the same thing for CD. That would be 3 minus 8 over 3 minus 1. I mean, if you need another one. You need one too. What would that slope be? So think about your parallel perpendicular definitions. Is this parallel, perpendicular, or neither? Go ahead, Linda. Perpendicular, because they're flipped, one's negative. You can either write that out or put the upside down T. Questions on that one? Then let's do number 3. Your slope for AB would be 6 minus 8 over 2 minus a negative 1. What would that slope be? Negative 2 over positive 3. Then find your CD slope. Which is 3 minus 2 over 3 minus negative 1. What would that slope be? Positive 1/4. Are these parallel, perpendicular, or neither? Neither. They're not the same. They're not reciprocals of each other. One is negative, but that's the only thing they have in common. So some other neither cases are if they have the same numbers, but one is negative. Those aren't parallel. If the numbers are flipped, but one isn't negative, those aren't perpendicular, so still neither. If the numbers aren't flipped, but one is negative, that would be similar to the not parallel, but that would still be a not perpendicular, so still neither. So keep in mind those things. On the back, some of you started number 4, that's fine. Move on to the next one. I want to do one more of these and then we'll move on to the next section. For 5, find the slopes of AB and CD. Before or you tell me what the actual slope is. What would this simplify to be? For AB? 7 plus 2, which would be 9 over 0. What would this bottom simplify to be? Zero over 3. As they are right now, are these parallel, perpendicular, or neither? What do you think? Otis? They're not the same. Why do you say that?
Because one is 0 and one is
Undefined. So, like this, you may not be able to tell, so you may guess a neither. But you have to know that this is undefined, and that this is 0, and that those are perpendicular. So that will be one that might trip you up. So make sure you know what undefined looks like, what 0 looks like, simplify it all the way, so you don't make that mistake. Questions about this so far? Regina, did you have a question? What is it about this question? Is it about something else? Which one? Mm-hmm. You just take this number and you flip it. If it was positive, you make it negative. Or if it was negative, you make it positive. So that's why this is negative over this. And then this is over 1. You take it, you flip it. It was positive, you make it negative. Same thing all the way across. Alright. Now we're going to jump to 9, where now we are given equations instead of slopes. But because we're given equations and some of these are in slope-intercept form, we can still determine, are these parallel, perpendicular, or neither? So for 9, are these parallel, perpendicular, or neither? Yes. And how do we know these are parallel? Slopes are the same and the y-intercepts are different. For 10, are those parallel, perpendicular, or neither? Otis? Perpendicular. Why?
because the slope is flipped.
One is negative and the slope is flipped. What about for 11? Otis? It looks like they should be parallel, but one is negative. Because of that, and they're not flipped, they're not perpendicular. So they're kind of. Now, some of your other ones are still equations, but now they're not in slope-intercept form. So we have to solve them first before we can determine that. So for 12, let's solve both of them. How would we solve this one on the left? Regina? Mm-hmm. So what is that new equation? Not 6x, we're dividing. It is plus 5 though. What would this fraction become? Negative 1 over 6x plus 5. Okay. Then solve the other one. This one is almost solved. We just have to divide everything by 3. What is that new equation?
6x minus 2, which would be
So here we have flipped slopes. One is negative, so these are perpendicular. Try number 14. I'll give you a minute to do that. These should have been the two equations you got, Regina. They'd be the exact same line. Oh. It'd be like y equals 3x plus 2, y equals 3x plus 2. It'd just be the same. Are these parallel, perpendicular, or neither?
upside down T, not like across it.
Correct. Upside down T. If you're just writing this simple. Our 15 is 15 parallel or perpendicular or neither. There's 3 options, not 2. Why do you say that? Because one is 1 and the other is negative 1, so those are perpendicular. What about 16? So here you have to think about your slopes. Because these are negative reciprocals of each other, that would be perpendicular. Wow, I don't know what that was. Okay. If you wanted to draw them, graph them, since these are kind of simple to graph, you could kind of do that off to the side. Like if this is my xy axis, and y equals 6 is up here, and x equals negative 1 is here. You can see that they make that T, so they would still be perpendicular. Questions on how to find if they are parallel, perpendicular, or neither from the slopes, or from ordered pairs, or from equations. So that is one of the Khan Academies. Can you determine what it is? Now I will say, it'll give you a fourth option. It'll ask you, are these the same line, Okay. It'll ask you, are these the same line? Are these strictly parallel lines? Something like that. Strictly perpendicular lines? Something like that. And then intersecting lines. So be careful with those. The intersecting is like your neither case. It's not parallel, it's not perpendicular, but they do cross at some point. The same line, they are exactly the same. So that's the difference with that. I know you have a neither parallel perpendicular page. That's for you to practice. Go on to the next page. So now we're going to take what we were doing before, writing equations and putting that together with parallel and perpendicular lines. So for this first part, we have to remember that parallel lines have, what do we know about their slopes? The same. And perpendicular lines have, what do we know about their slopes? What is that called? Negative reciprocal. Okay, so what's going to happen is we are going to be given an equation and a point. We want to write another equation that is parallel or perpendicular to the one they gave us. So we're going to use the equation they gave us to some extent. Like, we're going to ignore the y-intercept that they gave us because we don't need it. We really just need the slope from it. So off to the side, if you need this or want to write this down, I would write in your point slope because we're still using that. And then for number 1, we have we need to write an equation that passes through this point, so that's going to be your x1, y1, and it's parallel, so we know it's going to be the same slope to this line. If you want, you can cross out the y-intercept, because we don't need that. It's not going to be relevant, important to what we're about to do. If it's parallel to this line, what is our new line slope going to be? -4 is the number. So I would write that off to the side just so you don't get that confused. It'll also help you when we move on to perpendicular. Then we're going to take the slope, this slope, and our point and put it in this format. So y minus 7 equals -4 times x minus -2. If you want to go ahead and change that to a plus, you can. I'm going to do that next. Someone other than Otis and Gianna. You guys are killing it, but I need other people to answer. What is our next step? Yes. So y minus 7 equals -4x minus 8. And then our last step, Lacey. Add 7. So our new equation is y equals -4x minus 1. Notice that the y-intercepts are different. These two are parallel lines because the slope is the same and the y-intercept is different. We have now created a new line that is parallel to this one. So if we graph these two lines, they would never intersect. Questions so far? Let's try this next one. Same thing, but now the line is not in slope-intercept form. We have to get it in slope-intercept form before we can do anything else. I'm going to do that off to the sides so I have more space. So subtract your x to both sides. Divide everything by negative. What would that new equation become?
Y equals negative x.
So that is not the answer to our problem. It's just this same equation rewritten in slope-intercept form. So now if you want, you can ignore the y-intercept, cross it out because you don't need it. If we are writing a new equation that is parallel to this one, what will our new equation's slope be? Feels like a trick question, but it's just the same for now. So once you have your slope and your point, you can put it back in your point slope. Y minus -1 equals 1/3 times x minus 3. So I'm going to make this plus and distribute at the same time. And then subtract 1 on both sides. So y equals 1/3 x minus 2 is our new equation that is parallel to the original. They have the same slopes and different y-intercepts. What questions do we have so far? Now we're going to switch gears and do perpendicular. Same process, except we're going to have to change our slope before we do anything. So we're given a point, we have our equation that it's going to be perpendicular to, but our new slope has to be perpendicular to this, so we have to change the slope. What would that new slope be? Someone besides us, or Lacey, or I. You guys are answering great. Thne?
1/2.
Positive 1/2?
Or -1/2.
Negative 1/2. So if you don't do this, all the rest of your work is going to be messed up. You have to do this first. Right. Then, now that we have our new slope, we can go into that process. Y minus 3 equals -1/2 times x minus 4. And then keep solving. Y minus 3 equals -1/2 x plus 2. Add 3 to both sides. Y equals -1/2 x plus 5 is our line that is perpendicular to the original. The slopes are flipped and negative, or they are negative reciprocals. Y-intercepts, it doesn't matter. If you, maybe you forget to do it at the beginning, but you put it at the end, you will not get the right answer because your y-intercept will be different. So don't think that that will change anything. You have to do that at the beginning. Questions so far? Or is just like 2, but now we have to solve this equation first. So let's do that. Subtract your 5x to both sides. So we have -5 negative 5x minus 21. Divide everything by 3. So we have negative 5 over 3x minus 7. Before we continue, if you don't switch your slope, or maybe you change the negative but don't flip it, you'll notice that you'll end up with decimals or fractions where they should just work out to be nice numbers. Sometimes. Sometimes that's not the case, but so for our new equation, what would our new slope be? Positive 3 over 5. So use that slope and your point to write your new equation. So y minus 1 equals 3 over 5 times x minus a negative 5. Or you can go ahead and make that a plus. So what I'm doing next. Distribute your 3/5. So we have y minus 1 equals 3 over 5x. What is 3/5 times 5? Otis, you can answer this one. 3. Positive 3. Add 1 to both sides, and our equation is y equals 3/5 x plus 4. The slopes are flipped from the original and negative, or they are negative reciprocals, so y slope is not. How do we feel about writing equations from parallel and perpendicular lines? Good, okay, just need more practice. Not good, I don't understand what's going on at all. Alright. I want you to pick 1 from this first section and 1 from the second section. But if you pick one of the ones that's already solved for you in parallel, you have to do one of the ones that's not solved for you in perpendicular, or vice versa. So pick 1 from parallel, 1 from perpendicular, 1 from one of those that you have to solve the equation first. Okay. And then raise your hand so I'll check it, so I can check it. After I've checked that, you can work on more practice from this or Khan Academy. Where did it go?